Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, find the values of a, b, c and d such that g at x is equal to ax cubed plus bx squared plus cx plus d has a local maximum at 2, 4 and a local minimum at 0, 0. So in this problem, we have to find the values of these four constants a, b, c and d for this function g. Now we are given that this function has a local minimum at 0, 0. So we can start the analysis with this point 0, 0 because it is an easy point to use. So since the function has a local minimum at 0, 0, that means this point 0, 0 lies on this function. So we can sub in the function value as 0 and x as 0 in this given equation. So we get 0 equals a times 0 cubed plus b times 0 squared plus c times 0 plus d. Now we can simplify this equation. So a times 0 cubed will just be 0, same with b and c. So we are left with just 0 equals d. So this is the final answer for the value of d. So now we can rewrite our given function g at x as ax cubed plus bx squared plus cx. So the d term goes away because its value is equal to 0. Now we are also given that the function has a local maximum at 2, 4. That means this point 2, 4 lies on the function. So we can sub in the function value as 4 and x as 2. So we get 4 equals a times 2 cubed plus b times 2 squared plus c times 2. So now we can simplify this equation. So 4 equals, so 2 to the power 3 is 8. So we get 8a plus, now 2 square is equal to 4. We get 4b and then plus 2c. So this is our equation with a, b and c. Now we are given that the function has a local minimum at 0, 0. So that means that the graph of this function makes a valley at the point 0, 0 because it's a local minimum. So the tangent to this function at the point 0, 0 is horizontal because at a valley point the tangent will be a horizontal line. So the first step here is now to find the derivative of the function g at x. So prime of g at x is equal to, so in the first term is the coefficient, so it will stay as it is. And now we can use the power rule to find the derivative of x cubed. So we'll move the 3 to the front and we'll subtract 1 from. Now in the second term, b is the coefficient, so it will stay as it is. So in x squared, we can use the power rule. So the 2 will move to the front and we'll subtract 1 from 2. And in the third term, so the c is the coefficient, so c will stay as it is, and the derivative of x is just 1. So now we can simplify this equation. So prime of g x equals, so 3ax squared plus 2bx plus c. So as we just discussed, the derivative of this function will be equal to 0 at x equals 0 because at this point 0, 0 the tangent is horizontal. So we can sub in the left side as 0 and x as 0. So as a result, so now we can just move our analysis here. So the first term 3a 0 square becomes 0. So 2b times 0 becomes 0. So we are left with just 0 equals c. So this is the final answer for the value of c. Now we are given that the function has a local maximum at 2, 4. So that means the function forms a peak at the point 2, 4. So the tangent to the function at that point is horizontal. So that means the derivative should be equal to 0 at x equals 2. So now in the derivative equation, we'll sub in 0 on the left side and sub in x as 2. So we get 3a times 2 squared plus 2b times 2. Now the c term goes away because c is equal to 0. So now we have to simplify this equation. So we get 0 equals, now 2 square is 4 and 4 times 3 is 12. So we get 12a and 2 times 2 is 4. So plus 4b. So this is the second equation we get with a and b. Now the first equation that we got, we can get rid of the c term in that equation because c is equal to 0. So we can rewrite that equation as 4 equals 8a plus 4b. So these two equations together form a linear system for a and b, and we can solve these two equations using the elimination method because the b terms have the same coefficient. So if we subtract these terms, the b terms will cancel each other out. So 0 minus 4 is equal to negative 4 equals, and then 12a minus 8a equals 4a, and the b terms are gone. So now we can solve for a. So we can divide both sides by 4. So the 4's on the right side get cancelled out, and on the left side negative 4 divided by 4 is equal to negative 1. So a is equal to negative 1. So this should be the final answer for the value of a. And now we can find the value of b by subbing in a as negative 1 in either of these two equations in the linear system. So we can use the first equation. So 0 equals 12 times negative 1 plus 4b. Now we can simplify this equation. So 0 equals, so 12 times negative 1 is negative 12 plus 4b. And now we can isolate b by adding 12 to both sides. So the 12 on the right side will get cancelled out. So we are left with 12 equals 4b. And now we can divide both sides by 4. So the 4's on the right side get cancelled out. And on the left side, so 12 divided by 4 is equal to 3. So that means b is equal to 3. So this should be the final answer for the value of b. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to understand that the local minimum and local maximum points also lie on the function. So we can sub in the x and y coordinates from the given points into the equation. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.